Welcome to Haxby Shed. From the first time that I saw trepanning on David Wilks' channel, I wanted to make one of these, a tailstock trepanning tool. Just look at this, isn't it impressive? So in this series of videos, I'll explain how I made this and show you that it works. Welcome to part 1. When I made this reaction bracket for my tapping head, I had to make this annular ring. I started with a piece of solid, drilled it out and then bored it to the finished size. It took quite a long time and it wastes a lot of material. So I've been thinking for a while now whether or not I could make a trepanning tool. So I'm going to have a go. You can see the bits that I'm going to use to make this thing. Some 6mm key steel, some inserts, a nozzle for a coolant feed, a Morse taper 3 stub and a piece of scaffolding pipe which I found on the beach at Robin Hood's Bay, would you believe? In the sea actually. This is my design. I'm not really interested what size it turns out to be. So this is looking at the scaffolding pipe end on. These two black things here are the two inserts. And you can see this piece of key steel here, end on, and these will create the scrap channels. I'll cut these reliefs in here and here. And then the swarf, as it's cut, will run along the scrap channel. Now, the inserts aren't actually triangular. I think they're W form. And I don't have any way of cutting a triangular slot. So what I'll do is drill a small hole in there, which will take the point of the triangle and cut a recess for them to sit in. I've bought myself a 2.5mm tap for the insert screws. Now normally when I'm doing a project, I'm pretty confident about it. I'll usually get it to work some way or other. But this one is pretty tricky, and there's a decent chance that I will fail somehow or other. It requires me to TIG weld these pieces to this, and that in itself is a challenge for me because I'm just a TIG welding beginner. So we'll start by cleaning up the scaffolding pipe and see what we get to with that. I'm not certain what kind of material it is. I'm assuming that it's some kind of alloy steel. This end has been knocked about quite a bit, so I can't get a live centre into there, but it's pretty much round, so I'm going to put a fixed steady on and then machine this end, then I can get the live centre in. Good enough for this little operation. Should do. I'll just put a chamfer on the end of that pipe to suit this centre. Well, this is getting a bit complicated, but what I'm going to do is put this centre in, move this fixed steady back just out of the way. I'm going to machine a good steady band on the end here because this bar isn't completely round. Then move this away, set up the fixed steady again, and then machine out the bore. Not very round this, but I'm not going to keep machining it away. I think I've got enough off there. Well, that's gone as far as it's going to go, so now cut it to length. I need to make a collar to go on here and also to fit in there as a press fit to hold that in. Now if I do it now, obviously I've then got to work with all this extra length. But if I do it later, after I've cut slots in this tube here, it could be difficult to hold. So I think what I'm going to do is I'm going to make the collar. I may even press it on this end, but maybe I won't press it on this end until the end, just to give me some flexibility. We'll get this about right and then put a light steady band on it. I've got the fixed steady set up already, so I may as well use it. My target size for the bore is 25.5, so I've roughed it out here with a 24, and this is one of the drills that I sharpened on my homemade drill jig, so I'm pretty pleased with that. Don't know if you've seen that video, it's quite popular. These are the dimensions that I'm going for the collar bush thingy. So this tube, this is the collar here. So 25.4 hole through the middle to fit this taper adapter, 40.25 across the narrow dimension, and then probably with a lip on the end, which is maybe 5mm deep this way, 47.3mm, and then the whole job 30 long altogether, something like that. It's not critical, but at least if I've got a starting idea, I might land roughly where I need to be. So the first thing I'm going to do is machine 30mm off this, taking it down to a diameter of 48mm. It's 60mm bar. I wish I had 50mm bar because that would make this job very easy. I'll need to machine 6mm off each side to take the 12mm off down to 48, and then I'll trim it to suit. Right, well that's roughed out that major dimension. I was taking 1mm cuts there towards the end, and the old boy copes with it very well. I mean the lathe, by the way, not me. So, there we are. Got some nice coloured swarf there. This is only bright mild steel, so it's quite difficult to get a good finish on it. Next, to reduce this part to fit inside the tube as a press fit. This bore is a bit rough inside, but when I use the gauge and the micrometer on there, it looks like 40.35, so that's what I'll work to. There's a little bit of a ridge at the front here which doesn't help. Well, I'm happy with that. I've put a small lead on the front there. That just goes on. I'll probably heat this up before I press this in. There we are, that'll do. So then I'll machine out the bore now, this bore, and then I'll cut this off on the saw. I could use a parting tool. It's just easier for me to just cut it off on the saw. I'll put this back in the 3-jaw the other way around and just face off this end where I've cut it with the saw. I'm going to give myself loads of spare material. It's probably time I put a new blade in that Rapido. That was pretty slow, but I've had that blade in for a year or so and it's done its job. Change of plan. I'm actually going to bore it from this side. I know it won't be perfectly concentric with the outer, but it doesn't matter in this case. I want to leave it with a step at the bottom so that when I press in the Morse Taper 3 spigot, it bottoms on that step. There's about 1 mil diameter to come out of this. We're there, I think. I've just put a little bit of a lead in on it. Well, that's the easy bit done. As I said, I'm not going to press it together yet. I might need the space. I need to think about how I'm going to machine that tube. This thing is hard enough to explain, never mind make it. The wall thickness of the tube is finished at 3.5 millimeters. The inserts are 7 millimeters across and 2.7 millimeters deep. The key steel is 6 millimeters square. I'm looking for a web here 1 millimeter across. Above the inserts will be the scrap channel. So the scrap channel has to be 7 millimeters wide, otherwise the scrap would jam in the channel because the insert is 7 millimeters wide, so the cutting face is 7 millimeters wide. And the way that I've figured it out is I need to have a step across at this point so that this width here is 2 millimeters. And that will mean that my 7 millimeters of cutting face is supported here. But I'll have a part there where there's no cutting because that web will be there. So over this side, where I've got my tool upside down there, I've had to move the cutting tool across by 1 millimeter, and I'll have to cut away part of the web for that tool, for that insert to fit into. So that one will cut the web, where the web is, right to the core diameter of this tube. And this one, because it's moved out, will cut this section here, which is not covered by the insert on this side. This is how I'm planning to mount the key steel onto the side of the tube. You can see there's a fillet weld there. Now I don't know if that's going to be steel or bronze. It depends how confident I'm feeling with my TIG welding. But you can also see there's a little bit of a pocket there. Now imagine it without the insert. What I'm planning to do is to run a bit of bronze weld into that pocket there. I could theoretically steel weld it, but I don't think my TIG is good enough. I think trying to steel weld it, I think I just burn through this 1 millimeter web. I can't risk that. I've set up my homemade milling attachment and I've clocked it across here and at the back here to get it square in each direction. So now I need to mount the tube on it. Okay, here's the setup. I've got this in the right place. You'd think with these clamps that I wouldn't be able to move this up and down, but there's just enough spring in it, in these, for me to move it 1 millimetre or 2. I'm going to be climb milling, unfortunately, because this is going to feed in. But with the small cuts I'm taking, I don't think it's going to be a problem. Ideally, I would have come down here and gone that way, but I can't easily do that with these clamps, which are resisting the movement of this up and down. Here goes. Well, that's the cutting done on one side. I'll get it out, clean it up, and have to set it up the other way around and do the other side. I wish I only had to do one side. It's a lot more risky doing two, I think. The key steel would sit on that ledge just there. I probably can't hold this still. There you go, like that. Well, I think that's done, both sides. Good morning. I machined this offcut just the same as this. And I'll do some practice welds on here later on. But now we come to the tricky bit, because I need to fit this triangular 7mm carbide onto this 6 square millimetre piece of key steel. Because this is triangular, I need to drill an indexing hole somewhere about there. And we'll try this out and see if I can get it to work. I am considering buying some 7mm square carbide. I won't have the problem then with indexing, but it's £9 and I don't want to spend that unless I have to. The thing about these triangular carbides is they're shaped at the front, and I'm hoping that'll help to guide the tool and keep it running straight. I'll zoom in and I'll just show you what I mean. Look, see how it's curved at the front there. I've drilled my indexing hole halfway through, and now I'm going to shave 2.7mm off the top, as far to the left as halfway through that indexing hole. And you can see I'm using my magnetic chuck to hold it down. Although the chips do stick to the table, they're not as much of a problem as you might imagine actually. Well, theoretically this could work, but in practice it's too difficult. And I can't get the precision that I need with the equipment I've got. So I've ordered the square carbides, 7mm square, and that'll just make it so much easier. My son has just dropped his breaker bar on his favourite cup, which is left him with only half a cup of tea.